So when you guys are actually graphing absolute value, you have two steps. Alright, so you can follow the steps as I'm written right here in detail. You only need two things. You need to know what the vertex is, which is the little point right here, the pointy part of the V, because absolute value makes a V shape. You need to know that vertex, and you also need to know the slope of the sides, because it makes a V. What's interesting is that once you guys know the slope of one side, you're going to be finding the slope of the right-hand side. You can just reflect that over this line that goes down the middle, because it's symmetric. So once you know one slope, you would just do the reflection of that, and then you have the other side as well. So in order to find the vertex, this is what your function is going to look like up here. It's going to have a absolute value x minus h plus k. You guys remember how we talked about k was your up versus down when we were doing transformations? And we talked about h, which is inside of your parentheses or inside of your function. That's your left versus right. Remember that from unit 0? So in order to find the vertex, all you have to do is take h and k, those two numbers right there, and you write them as a point. The only thing you have to pay attention to is that, just like we saw in unit 0, h, whatever is inside of your function, you have to think the opposite of what you would normally expect. So when we were doing transformations and you guys saw minus h, remember that was going to the right instead of the left, because you guys have to think opposite of what you would normally expect. Same thing happens here. When you guys are writing the point, h is going to be the opposite sign of what you see, so it's like minus 1. It would really turn into a positive 1 when you write it as a vertex. But the k, the number on the outside, stays the same. So just remember, anything from the inside of the function, whether it's parentheses or absolute value, when you pull it out, it's going to change sign. If there's nothing there, it would be a 0 for either h or k. So that's how you find the vertex. And then to find the slope, that's just a. The number in the front, that's usually where our inflection or our compressor stretch would be. That's going to represent the slope. And then you just reflect that over this line that goes through the middle, it's symmetric, so you get a slope on the other side. So two really simple ways of graphing, or two things that you need, really simple to find in order to graph. So I have this example right here. Right, this is our equation. The vertex would be 2, negative 3. Why is it 2, negative 3? Okay, so this right here would be h, right? When I pull it outside of the absolute value and put it into the point, it changes sign. Do you guys see that? Okay, why is this negative 3? On the outside, but it doesn't change. Okay, so I just take those two numbers, that's similar vertex, and then x equals 2 is going to be what I call the axis. This line that goes through the middle, that line of symmetry. Again, the axis is just whatever a is. So, oh, why does that say? Oh, sorry, that's not a. My bad. The axis is always whatever h is. So whatever the x value is for your vertex, if you draw a vertical line, that's going to go right through the middle. And then why would my slope be 1 over 1? Yes? Looking for a slightly different answer. Daniel? Why is the slope 1 over 1? Okay. Where do we look for the slope again? Look at the very top of the page. Slope is what? A. And A is usually right here in front of the absolute value. Remember, when you guys don't see something and it's a coefficient, it's a 1. Okay? So that's why the slope is 1 over 1. So this is how you graph it. You go to 2, negative 3, you draw a dot. And if the slope is 1, you go up 1 over 1, up 1 over 1, up 1 over 1. And then you do that on the left. And that's how you draw it. Really simple. This is another example right here. This time, this is the function I have. Why is the vertex negative 1, 3? Okay, so this is a positive 1 inside. So what does it turn into when you take it out? Negative 1. And then the positive 3 is at the end. Doesn't change sign, right? So it stays 3. So our vertex is these two numbers where this one changes down, it stays the same. The axis, which is that line that goes straight down the middle, is going to be the same value as the x value from the vertex. And then your, why is my slope negative 1 over 1 for this one? Because the number at the very front, in front of the absolute value, is a negative 1. So that's why my slope is negative 1. You can see I go to negative 1, 3, and then I have a slope of negative 1 on that side, and the reflection on the other side. So graphing an absolute value equation is actually really simple. You just need to know how to work with the function in order to find the information, and then execute it. I'm assuming you guys know how to graph lines. It's an important thing to have the background for this. So let's look at our examples here that are blank, not done for us yet. We're going to look at example number 1. G of x is equal to negative 1/2 absolute value of x equals 3. What would my vertex be? Remember, you just need two things, what the vertex is and what the slope is. What's the vertex? Nope. Nope. 0, comma, 3. Was there a number to actually take out of the absolute value to change sign? No. If either of those two numbers is missing, if there's no h inside of the absolute value or there's no k outside of the absolute value, those are just 0. And don't make up numbers like 1. Okay? It's a 0 if it's not there. Alright, what's my slope? Negative 1/2. Or negative 1 divided by 2. It's just a, whatever the number is at the very, very front of the absolute value. Now all you guys have to do is to go to 0, 3. Right there. Draw a dot. To your vertex. Draw a little dashed line that goes through your vertex, a vertical line that's called the axis. It's going to show where our holding point is because they're asymmetric. And then you're going to use the slope of down 1 over 2. Down 1 over 2. Down 1 over 2. Assuming you guys know how to do slope of fractions. Okay? That's one side of the v. Now all I have to do is reflect that over the line and switch to the other side. So instead of going down 1 and then over to the right, I'm going to go down 1 over to the left. Same slope, 1 over 2. Same slope on both sides. And then you draw your line, and that's the absolute value. Alright? What about example 2? What would my vertex be over here? Negative 1, negative 3. The number inside of the absolute value is going to change sign, and the number outside is going to stay the same as the two numbers we used for the vertex. What's my slope? 2 over 1 if I were to try it as a fraction. My slope using a, the number of the front, 2 over 1. So I go to negative 1, negative 3, which is right here, and draw my little axes to show where the middle is. I'm going to use the slope of 2, so up 2 over 1, up 2 over 1, up 2 over 1. Draw at least 2 or 3 points using the slope, so you can see because you're counting correctly. And then do the same thing, but instead of going to the right, you're going to go to the left. Same slope, but reflected over our line of reflection here. Now just to recap really quick, let's go over the transformations that occurred. Let's review. For this one right here, what transformations occurred? What does this little negative do? The negative on the outside reflects over the x-axis. What does the 1/2 do? Compress by 1/2. And then what does this plus 3 at the very end do? Plus 3. Good. What is this 2? For the next equation, what is the 2 at the front? Stretch by 2. What does a plus 1 on the inside do? Left. Remember, you think opposite, so I go left 1, and then the minus 3 at the end. Down 3. So don't forget to be reminding yourself what those transformations are. You're so responsible for knowing what the transformations are. We're just not using the transformations to graph it like we did in the video. That was complicated, remember what the order was and all that. So now we have this other method of graphing. You should know what the transformations are, but you kind of confuse them with graphing. Okay. What about this one? That's my vertex. 1, 3, and my slope. Negative 1 over 1. Okay, so I'm going to go to 1, 1, 2, 3. Have my axis, look right down the middle. And then my slope, I go down 1 over 1. Do what if you're just graphing the line. Okay. One reason why I put this line of symmetry in here is to show you that when you guys are doing the slope, you shouldn't keep going. When you guys are graphing lines, you usually go underneath the point and then above the point to get that straight line. When you guys are drawing your V, it should change direction. That's why I personally like to draw that line of symmetry, so that I know not to keep going like a straight line. I can change directions and start going down, like this. So that line of symmetry is where you change directions. The vertex is where you change directions. what are the transformations for that one? Reflect over x-axis, right one, and up 3. So you guys can see from both the picture and the equation. Alright, go ahead and try the last one on your own. Alright, what's the vertex? 0, -2. Remember the number on the end does stay the same sign. Slope? Over 4, 1/4. So you're going to go to your vertex, and then you go up 1, and then over 1, 2, 3, 4. So this is a very shallow V. What are the transformations that took place? It was compressed, that's why it's so shallow, so flattened out. And it went down. Okay. So you can see, after you graph the picture, you can compare the picture to the equation. You can use both of those together to figure out what the transformations are. Any questions on how to graph?
So do the same thing with the base absolute value of normal.
Well, but if it's not absolute value, the shape would not look like this. So, not exactly. But because, are you talking about just the sign change?
The way we graph it, are we able to use it?
No. Because again, the absolute value specifically has that V shape. If it was just parentheses, that would technically be a line. So, you would not use the same process to graph that. You'll see if we go on and see parentheses with a square on the outside, that is a quadratic and would be a U. We're going to have our own special way of graphing that. So you'll see every time we get to a new type of graph, we have a different method for graphing. Okay? Alright, now we're going to do the other side of the coin. I'm going to give you guys the picture. You're going to tell me what the equation is. Okay? And it's going to need the same piece of information. You guys need to find what the vertex is. You guys need to find what the slope would be. And then you're going to put those back into the function. So here's our vertex. What is that point? Okay, so let's write that. And then I'm going to ask you for the slope. Now when I ask you the slope, you should only look at the right side. Because remember, the left side is our reflection. So look at the right side of your function and tell me what the slope would be. Okay, so those are our pieces of information. I need to start putting those pieces back into the function. So you're going to start with y or f of x equals. And then how would I proceed from there? Nothing else inside? That's 4 minus 1. Okay. Now, the slope was 1/1. If you guys want to write 1/1 in front of the absolute value, you can, but you don't need to. If you guys multiply times 1, you don't need to write it. And then also you guys could write s minus 0 inside, but again, that would not be technical. Like if I were to give you multiple choice answers, you wouldn't see minus 0 anywhere. But that's technically what's going on. You're doing x minus 0. That's why there's nothing inside of the absolute value. But officially, this is what the simplified form of the function looks like. Does everybody see the connection? Okay. What is the vertex for this one? -1, 4. Okay? And then what's the slope? And again, make sure you guys are looking at the right side. What is the slope? You decrease, or you go down 1 and then to the right 3. So how would that be represented as a slope? -1/3, right? Okay. So again, I'm going to start with y or f of x equals, and then how would I piece together? So remember, a, your slope is in the very front. Plus, remember it changes sign between the function and the vertex. That first number to change sign, and then plus. Don't forget that. I know it's tricky to remember that it changes sign, but that's one of the most important things you have to remember. Alright, everybody see that one? Okay, so our vertex is 4, 1, so that's why it's -4 and +1. Opposite sign in here, and then the slope is 1/2 sign in the vertex. Okay. Alright, what about f of x? Anybody for f of x? Yeah. Yep. Same thing, the vertex was -2, -3, so it becomes +2 inside of the absolute value, and the -2, 6, and the slope was -4. All right, that was our first and third learning target, being able to graph a function and, given the graph, write the equation. Everybody okay with those? Okay. Our next thing that we're going to talk about is how to do the same thing, but what happens when you change it to an inequality. So just like our simplified split solve became a little bit more complicated last class with the inequalities, we had to remember to switch the symbol for the second equation. You made it negative and all the extra stuff that you have to pay attention to. Same thing here. So once you change it to inequality, there are a couple more details you guys have to pay attention to. And hopefully if you guys graphed inequalities like lines in Algebra 1, some of this will be familiar. So you guys still need to find vertex, you still need to find the slope, but in addition to that, you guys will need to determine the type of boundary line. When you guys draw your V, it's either going to be a solid line or a dashed line. Okay? So if for inequality is either greater than or less than, it's going to be dashed. You're going to draw like a dotted or dashed line. However, if it's greater than or equal to, or less than or equal to, you have that equal to part, then it's going to be a solid line. A solid line represents equality. That's why we were just doing equations. That's why we had a solid line. But if there's no equality involved, then it has to be dashed. Alright, so once you guys have made that determination, I always want you guys to do that first. So you're reminding yourself as you're going through whether it should be dashed or solid and you actually graph it. You do what we just did before. Right, you would find the vertex and the slope the exact same way. And then once you guys have graphed your V, whether it's solid or dashed, you're also going to have to shade. There's shading involved. So you're either going to shade above the graph or below the graph. And the way you determine whether you're going to do above or below, if it's a greater than, which way do you think you would go? Above. If you're going to be greater than your V, your graph, you need to shade above. So if you see a greater than or equal to, you're going to shade above the graph. And if it's less than or equal to, you guys are going to shade below. Okay, so two extra things to pay attention to besides just the vertex and slope. You have to know whether it's dashed or solid line and whether you're shading up or down. A couple more details. Let's go ahead and look at these examples. Let's start with our solid versus dashed. So, look at the inequality symbols. I'm going to be a solid or a dashed line. It is solid because it has equality. Alright, then you guys move on to the important details of the vertex and slope would be. So what's the vertex? 1, 0. Remember, when either H or K are missing, you don't physically see a number there, you just stick a 0. And the negative becomes positive when you pull it out of the absolute value. That's my slope. 1. And then lastly, I want you guys to take note, should I do shading above my V or below? Above, because it's greater than. Since you have all this written down, now we can get started. So let's go to our vertex, which is going to be at 1, 0 right here. You're going to start by drawing the little dot like we did on the previous page. You can go up 1 over 1, up 1 over 1, right? Reflect that over the vertex, over that line of symmetry. And the reason why I draw the little dot for the slope first is so I don't automatically draw a straight line, because that's not always going to be the case. Once you guys are here, I want you to pick up your pencil, put it down, think for a second, remind yourself, am I drawing a solid line or a dashed line? Solid. Pick up your pencil again, draw your solid line. Remember, it's not always going to be solid. Sometimes you'll have to draw a dashed line. You have to stop yourself and think about it. Now that I've drawn my graph, there's shading that we have to do. So I'm going to shade above or below? Above. That's going to be here. Above the V just means everything that's from the sides of the V up. So it's also inside, but I don't want you guys to think inside, outside. I want you to think above. You would have done something like this with lines and on for 1. Alright, what about example 2? Something new happens here. Okay? Yes, we're going to need to get y by itself before we can start. So I've thrown a couple of examples in here where you guys have to manipulate the function or the inequality a little bit before you can use the graph. So in order to graph something, y needs to be by itself. So all you guys have to do is rewrite this really quick. You're going to have to subtract 4. Just be prepared to see something like that where it's not ready to graph yet. So subtract the 4 over, and then once you have y by itself, graph it. Right. Step number 1 is simply a solid or a dashed line. Dash. Because there's no equality. Okay. What is my vertex? 0, -4. There's no number inside the absolute value, so it's 0, and then around the outside, -4. What is my slope? 2 or 2 over 1. And then am I going to be shading above or below? Above. Greater than. Alright, so let's go ahead and graph our vertex. Right here. So our slope is up 2 over 1. Always start with just the dots. See what your path should look like. Then put your pencil down or you pause for a second. Okay, I've set up a skeleton for my graph. Should I draw a straight line or a solid line or a dashed line? Dash. So you're gonna draw like this. Dashes like that. And going in between your little dots. You can see it's not solid. And then because we're shading above, when you guys are trying to graph this, what's the first thing you check for? Solid versus dash. Which one would this be? Okay. Then you guys want to find your vertex and your slope. So what would the vertex be for this one? 3. Remember, it's very simple. All you do is take the number on the inside and the number at the end. Those are the 2 numbers we use for the vertex, except the one on the inside changes sign. That's it. What about the slope? Slope is always the value at the very, very front, in front of the absolute value. So that's 2 or 2 over 1. And then am I going to be shading above or below? This one's below because it's the last one. So I'm going to go to my vertex. 1, 3, right here. My slope is 2. I'm going to do that to the right and then to the left, so I get that symmetrical V. Stop for a second, recheck. I wrote down that it's solid. And I'm shading below, so it's going to be all of this. Okay? What about this one, number 4? You have to rewrite the equation because it's not solved for y. Right now it's negative y. Can't have that. What do I do? Divide by -1. What's that going to do? It's going to switch the inequality, make the absolute value negative, and then make that a -3. You have to change the sign across the entire thing. So anything that's on the left-hand side with y that shouldn't be there, you have to take care of that before you start working through defining the equation. Okay? So make sure it's solid for y first. Your eyes peeled. So this is going to be solid or dash. What would my vertex be? Is there anything inside the absolute value bars? Okay, so my first number, which is supposed to come from the absolute value bars, there isn't anything there, so I put a 0. My second number comes from the outside at the end, which is -3. And then my slope comes from the very, very front, in front of the absolute value, -1. And then am I going to be shading up or down? Alright, so vertex right here, slope. And then this is dash, so again, double check before you jump into graphing. I know you guys are going to feel like instinctually draw a solid line, so you always got to check. And then shading above. All that. Okay? Everybody good okay with those last 2? So a couple more details to pay attention to. We've got to be extra careful with the inequalities, just like we were for solving. Alright, almost done. Now we're just going to do the reverse like we did on the previous page. So the picture for you, I'd like to know what. So looking at this one, again, you want to make that same checklist. Is this solid or dash? solid, so we have that. What's my vertex? 0, 0, that's going to be interesting. What's my slope? Again, always look at the right-hand side, so negative 1 over 1. And then am I shading above or below? Above. Okay. So with the first and the last pieces of information, the solid and the above, which inequality am I going to have? Greater than or equal to? Because it's shading above, we know it's a greater than. And because we have that solid piece, we know it's going to be greater than or equal to. So the equality. Alright, now my slope is negative 1. Because the vertex is 0, 0, there is no number inside of the absolute value, and there's no number on the outside of the absolute value. Yeah, 0. Okay. Same process. Next one. Solid or dash? The vertex. 2, negative 5. Okay, what's my slope? Yeah, I think it's 1 over 1. Or 2 over 2, which implies 1 over 1. Sorry, hitting up or down? Up or above? Okay, so again, with the dash and the above together, which inequality is that? Greater than? It's not greater than or equal to? Why is it not greater than or equal to? Dash, not solid. Solid means equality. So that's missing, there's no equality. My slope is just 1, so I don't need to write a. You can write 1 if you want to, but I'm not going to. So it's the absolute value of x minus 2. Remember, the first number of your vertex came from inside of the absolute value, but is the opposite sign. And then what should it be at the end? Minus 5. Because the second number from the vertex is at the end. Alright, everybody get that one? Okay, go ahead and do the last one for us. Everybody get that? Good thinking. Alright, so that was our second and third learning target, being able to graph an absolute value inequality, and then also based on the picture to generate its equation. Any questions about that? Okay. So you guys have